Okay guys, let's take a look at our chain rule day 2. Hopefully this lesson actually is going to be more simple, I think. It is very abstract, but at least we just have one function embedded inside another instead of the whole string like we had on the other lesson. So I'm thinking that you probably will find this lesson a little bit easier than the first one. It still is abstract though. We've got to, use a graph or data points, or a table to create the derivatives, but other than that, it's fairly straightforward. All right, so let's take a look at our first example. They tell us that f is the function whose graph is shown, and then they define h of x and g of x. So h of x is f of x, and g of x is f of x squared. So just a couple little different things going on. They want us to use the graph to estimate the value of the derivative of h at 2 and of g at 2. So that's our task. And like we've done before, I'm going to just find the derivative of h with an x in it. Then I'm going to put the 2 in. We're going to work it just like we did some previous problems. So let's work on the h one first. So h prime of x. So what I do is I take the derivative of the outside. That would be f prime. Copy paste the inside, then I take the derivative of the inside. Okay, that's pretty much, that's just the chain rule. So we take the derivative of the outside, copy paste the inside, and then multiply by the derivative of the inside. My second round, I'm going to go through and change all the x's to 2's. And again, I'm showing you every single step. You don't necessarily have to show all of that. So we're going to say h prime of 2 equals f prime of f of 2 times f prime of 2. Alright, so we're required here to get this function value f of 2. I go to my graph, there's 2, and so f of 2 would be 1. Okay, so we would go ahead and put a 1 in place of f of 2. So h prime of 2 is going to be f prime of 1, f prime of 2. Okay, and up to this point we should all match. Now once we start estimating derivatives off the graph, it's just an estimate and our answers are going to vary. They can vary actually quite a bit. So I really don't like to put an estimation problem on a quiz or a test because the answers are so varied. But it is important that we see it and know how to do it. So what we would do is we would estimate the derivative at 1 and at 2. So I'd go over to 1, draw a little line here, go over to 2, draw a little tangent line, and I would make an estimate. The estimate of f prime of 1, I put at negative 2/3. Certainly could have been negative 1/2 or even negative 1. You might have even seen that as a negative 1. If you wanted to get 2 points and try to figure it out, you might get a little closer. But again, we're just estimating. And then the derivative at 2, I calculated that or estimated that to be negative 1. So my entire derivative would be 2/3. And those are just taking estimates. Again, it's just an estimate. Yours could certainly vary. Okay, is that okay? Alright, let's take a look at the g. We're going to do g prime of x. So that's this function right here, g prime of x. So I take the derivative of the outside, f prime, copy paste the inside, and then take the derivative of the inside. Just a little bit of a different one, but still just using the chain rule. Now I'm going to go through and I'm going to put a 2 everywhere there's an x. So g prime of 2 equals f prime of 2 squared, and then 2 times 2. Okay, so then we have g prime of 2 equals f prime of 4 times 4. So we go back over here. Here's 4. F prime of 4 would be a derivative value here. Looks a little steeper than 1. Maybe it's a 4. I don't know. It would be an estimate. I would probably estimate it at a 4. Where are we? Or let's see, what did I estimate it at? This guy right here. Okay, so this is a 1. Okay, that's a 1. A 2 would be a little bit, again, it's an estimate. We're not going to we're not going to get a little bent out of shape about it. We could do 2, 3. I mean, so you see where the range of estimates would be, why we wouldn't do this on a quiz or a test, but we do need to be comfortable with knowing how to estimate a derivative off of a graph. So, you know, we'll say it's a 3 or 4. It doesn't, again, it's an estimate. So g prime of 2 would be about, if you had one of these on a quiz or a test, I would give you more information so that you could actually find it better. You could do a better job of finding the actual answer. Okay, and that's off of the graph. Is everybody okay with that? All right, so let's take a look at this next one. The next one has data points, and we're wanting to find w prime of 0. And so hopefully you recognize that little O from that notation from last year. I don't know if you remember it in pre-cal or not. The books love to use that notation. I actually don't like it that much, but we need to know what it means. If I wrote it in this format, this is the format that I prefer actually. If I wrote it in that format, it would be W equals U of V of X. That's what that little O means. It means that this is a composite function and V is the inside function. But I actually prefer that notation. But we need to be familiar with this. All right, so we want to find the derivative. So W prime, we would take the derivative of the outside, U prime, copy paste the inside, then take the derivative of the inside. Okay. Then I would go through and substitute W0 in. So W prime of 0 would be U prime of V of 0 times V prime of 0. Okay, I'm not going too fast, am I? Are we okay? All right. We have a function value, this little guy right here, that we need to, let's see, it's right here. So we have W prime of 0 equals U prime of 2, V prime of 0. And there we go. Hopefully they gave us all the information that we need. And in fact, you'll notice they gave us more than we need. And that's really intentional on their part to make sure that you know how to do the chain rule. They're going to give you extra information just to see if you'll use it. Just because it's there doesn't mean that we use it, right? We use it only if we need it. And so U prime of 2 is here. So that's a 4. And V prime of 0 is here. That's a 5. And so W prime of 0 is going to be 20. Okay, is that okay? All right, pretty straightforward. I know we've done problems like this before in different contexts. I think we did some product rule ones and quotient rule ones. We've just done some different ones. Now we're doing chain rule. All right, the last one is where we're going to use a table to estimate the value of h prime of 0.5. So the derivative at 0.5. So h prime of x, okay, here's our definition right here, what h of x is. Where, of course, it's an embedded function. We're going to do the chain rule. So that would be f prime of g of x times g prime of x. And we want it at 0.5, so h prime of 0.5 equals f prime of g of 0.5, and then g prime of 0.5. I'm not going too fast, am I? Are we okay? Okay. All right, so the function value should be pretty straightforward for us to get. Hopefully they have it in the chart for us. This little guy right here. We just need g of 0.5. So here's our g function. And 0.5 is here, so g of 0.5 would be 0.1. So that equals f prime of 0.1 times g prime of 0.5. Now, when we're estimating derivatives off of a chart, we kind of have to rely on our last resort, don't we? I mean, we don't have a graph, we don't have a function, we don't have pretty much any other way to estimate besides Yes, besides our slope of the secant or average rate of change. That's all we have. I mean, it's our last resort. That's not our first thing we would go to estimate a derivative, but when all else fails, we go to the slope of the secant. And the easiest thing to do, or what I would advise for you to do, is to go to this, point 1, and reach to either side. Use either side. So your endpoints of your secant would be at 0 and point 2. And so therefore, let's see, this one is f. Therefore, we would be using these y values. Okay, so these are the values that we're going to use as our endpoints of our secant line. So let's do that. So f prime of point 1 would be 18.4 minus 12.6. That's a difference in y's. 0.2 minus 0. And we work that all out, and strangely enough, we get an integer, 29. Okay? So then we go to g prime of 0.5. And let's change colors here. So I want to find, g of 0.5. So here's the 0.5. We're going to reach on either side of it, and we're going to use either side. So we're going to use these two x values, and then we're using g, so it's going to be these two that we're going to work with in finding our derivative estimate. Alright, so let's do that. So then we have 0.05 minus 0.17 over 0.6 minus 0.4. And after all that arithmetic is done, we get negative 0.6. And so our final answer, we would do 29, that's f prime of 0.1, times negative 0.6, which is g prime of 0.5, and that gives me negative 17.4. A little more accurate technique than that first graph one that we did. So I'm more likely to give you one like these two right here rather than the graph one. Okay? How are we on this? Bit easier than the first day, right? I mean, it's just really a function embedded inside of a function. We don't have the crazy, nesting things. All right.